Okay, we'll do our topic 8 worksheet now. I'll probably split this over by 2 videos. The last topic that we'll look at is basically the stuff that I would be covering here in chapter 6. We're going to skip section 6.2, so 6.1, 6.3, and 6.4. We'll get right to it. So we're talking about systems of equations. A system is where you have one or more equations with one or more unknowns. Usually we use a brace to enclose all the equations there, and there's 4 methods for solving a system. The graphing method, the substitution method, the elimination method, and then using matrices. So we'll look at all 4 here. Problem 1, use the graphing method to solve the system that's given there. Okay, so when we use the graphing method, we're just going to graph 2 lines and see where they intersect. So the first line has a slope of -2 and a y-intercept at 6. I'm starting at 0, 6 here. And then work off of the slope. We're going to go up 2 into the left one, or can also go down 2 into the right one. If you do that a couple of times, this line will pass through the point 3, 0. And I've drawn that first line there. The second line, y equal 1/2 x minus 4, that has a slope of 1/2 and a y-intercept at -4. So here's I'm starting at 0, -4 on the y-axis, and then using the slope going up 1 and to the right 2. Okay, and it looks like these 2 lines are going to pass through the point 4, -2. You can check that. Okay, if x is 4 and y is -2, let's see here, -8 plus 6 is -2, and then 1/2 times 4 is 2, minus 4 is -2 for y. That looks good. Okay, now the fact that both of these lines are in the form y equal mx plus b suggests that it might be a good option to use the graphing method there. The graphing method isn't always a great method because if you don't get nice counting number values there, it might be hard to see the actual values, the exact numbers there on a graph. Problem 2, okay, we're using the substitution method to solve each system. Here's the first one. I'm going to use the substitution method, and when I do that, I want to select an equation and then solve for that variable. It doesn't matter what equation, and it doesn't matter what variable. If I were to solve the top equation for x, subtract 3y from both sides, then I'm going to substitute that into the bottom equation there where I see x. And so I've done that. That allows me to have an equation completely in terms of y, which kind of puts me back on more familiar ground in that I've only got 1 variable now and not 2 variables. So we'll solve for y, distribute 3 into both of these terms, and then collect your like terms. -9y minus 4y is -13y. Subtract 57 from both sides, and you get -78 there on the right. Divide by -13, and it looks like y is 6. Knowing that y is 6 means that I can plug that back into my substitution equation to get x. So I've done that. -18 plus 19 is 1. So it looks like x is 1 and y is 6. I can check that. 1 plus 18 is 19. That's true. And then 3 minus 24 is -21. That's also true. It's a good idea to check your answers if you're unsure, or just to double check to make sure that they are correct. So, by the way, we like it when there's a 1 or a -1 in front of x or y for using the substitution method. You see, I could have used the second equation here and solved for y. That would have been fine. I would have found x first if I did that. But I also would have introduced fractions into the calculation early on, and that's not really ideal to be right away working with fractions, although I could have done that, though. Here's another example. Okay, so again, I'm going to use the substitution method, and let's select the top equation and solve for y. I like the 1 in front of y there. If we add 2x to both sides, then y is 2x minus 1, and I'm going to substitute that into the bottom equation where I see y. I've done that, so that way everything will be in terms of x, and I can then solve this equation to get x, and once I have that number, I can then figure out what y is. So I'm distributing the -7 here into these 2 terms. Collecting the like terms, I've subtracted 7 from both sides. Negative 11x equal 22. If you divide by negative 11, that means that x is negative 2. And knowing that x is negative 2 means that I can get y by plugging that into my substitution equation here. Negative 4 minus 1 is negative 5. So x equal negative 2 and y equal negative 5 would be the right answer there. Okay, and then there's also the elimination method. We sometimes call the elimination method the addition method, since we're going to be adding equations and their like terms here. Most books use the term elimination method, so let's use that in these two systems. Okay, and the first one, why don't I eliminate x by multiplying the bottom equation by negative 4 on both sides. If I do that and then I add the equations together, meaning that I add the like terms together, x would be eliminated. So check it out. If I take 12x minus 12x, that's 0. X is eliminated, and that's what I wanted. 9y minus 20y is negative 11y. And then negative 69, it's going to be plus 124 is 55. And if you then divide by negative 11, y would be equal to negative 5. Okay, so knowing that y is negative 5 means I can get x by plugging that number into either one of these two equations. It looks like I'm using the bottom equation. Plug in negative 5 there where we see y. 3x minus 25 equal negative 31 if you add 25 to both sides. 3x equal negative 6 divided by 3. It looks like x is negative 2. Okay, so I can check that here. Negative 24 minus 45 is negative 69. That looks good. And then negative 6 minus 25 is negative 31. That looks good. I didn't need to eliminate x. I could have eliminated y. That would have been fine. In doing that, I suppose I would need to multiply the top equation by negative 5 and then the bottom equation by 9, so I'd have to work with both equations there, but still I would be able to get the same answer though. Here's another example. So again, we're using the elimination method. I'm going to eliminate x by multiplying the top equation by 4 and the bottom equation by negative 6. Be sure that you do that on both sides, okay? And then we're going to add the terms here. Negative 24x plus 24x is 0. X is eliminated. That's what I wanted. And then 36y minus 36y is 0. So y actually gets eliminated also. And then if you take 4 times 17, that would give you 68. Minus 72 is negative 4. And you're saying 0 equal negative 4. Of course, that's not true. Both the variables were eliminated, though, and you ended up getting something that was false. That means that we have an inconsistent system. An inconsistent system just simply means that there's no solutions to the system. In other words, it's not going to matter what you do. If you go through this procedure using the elimination method, you'll always have something that's false, like 0 equal negative 4. That's false. The empty set sign is also a symbolic way to represent no solutions. Okay, on this one we're using substitution or elimination to solve. Part A, I'm using the substitution method, so if I add x to both sides and subtract 8 from both sides, then x would be equal to 6y minus 8. I can then plug that into the top equation for where I see x, and so I've done that. Distribute the 3 there, and then collect your like terms. 16y equal 28. If you divide by 16, y is equal to 28 over 16, which would reduce to 7 over 4. Of course, you know, simplify as far as you can go there. Knowing that y is 7 over 4 means that I can get x by plugging that into my substitution equation. 6 times 7 over 4, let's see, 42 divided by 4 is is excuse me. Yeah, let's look at it as, yeah, 42 divided by 4 reduces to 21 over 2. 8, that's the same as 16 over 2, so I've got my common denominator there. Subtract, you get 5 over 2 then for x. So x is 5 over 2, y is 7 over 4 should be the right answer there. Of course, give the exact form, okay? You got to be careful with using decimals and rounding. If, you know, my math lab is wanting the exact form, just be careful about that. All right, here's another one. So again, substitution or elimination. I went with elimination on this one. I'm going to eliminate x. So if we multiply the top equation by 4 and the bottom equation by 6 and then add, we'll eliminate x. Here's 24x minus 24x is 0. But then negative 60y plus 60y is 0. So y actually gets eliminated also. On the right, 48 minus 48 is 0. So we end up getting 0 equals 0, which we already know 0 equals itself. But this is a true statement, right? Unlike in the last problem there, we had 0 equal negative 4. That's not true. This is a true statement. In this problem, we have a dependent system. A dependent system just simply means that there are infinitely many solutions to the system. In other words, it's not going to matter the ordered pair that you go with because there's going to be infinitely many possibilities, and that you'll always get 0 equals 0 if you go through the elimination method here. When you give your answer, you want to write it as an ordered pair, x, y, but everything either has to be in terms of x or everything has to be in terms of y. I went with x. So in the y coordinate position, I'm going to have to know what y is in terms of x. If I select the bottom equation and solve for y, I've done that, add 4x and then divide by 10, I'm getting y equaled 2/5 x minus 4/5. And so I'm writing that expression then in the y coordinate. That way everything is in terms of x. Now, this is one way to describe to somebody that there are infinitely many solutions. In other words, if you give me any number for x, you can, of course, there's infinitely many choices. You'd be any number for x. I can always find the y value by taking 2/5 times that number minus 4/5. So you can give me infinitely many numbers, and therefore I can be able to generate infinitely many points, which would be solutions. A dependent system just simply means that you have the same line drawn twice, okay? And then an inconsistent system means that you have two lines, but they're parallel, and so therefore they'll never intersect. Why don't we try just one more here in this video? So problem 5, we want to, it says adults are charged $6 and children are charged $4 to see a play. Last night, 103 people saw a play, paying a total of $532. How many adults and how many children were at the play? So let's let X be the number of adults and let's let Y be the number of children. We want to form a system representing the situation here. There were 103 people that saw the play. So if you take the number of adults plus the number of children, you get 103 total. That's how I'm getting my first equation there. The second equation is this cost equation. Adults are charged $6, children are charged $4. So if you take the total cost of all the adults plus the total cost of all the children, you get $532 total cost for that night. Now that I've got my system formed, I can solve using whatever method I want. I went with substitution here, and so I'm going to solve the top equation for y and then substitute that into the bottom equation where I see y. That way everything is in terms of x. Solve for x, distribute the 4 there. Okay, 6x minus 4x is 2x. Subtract 412 from both sides, you get 120 there on the right. Divide by 2, so it looks like x is 60. There were 60 adults that were at the play, and then knowing that x is 60 means that I could get y by plugging that number into my substitution equation. Negative 60 plus 103 is 43 children then that were at the play. So that would be the right answer there for problem 5.